Okay, y'all, welcome to Toolkit number 13. From here for the next like 6 or 7, this part of this first semester, we're really going to be diving into kind of financial management, a lot of money stuff, right? You can see below, this is like, if I save money, how much can I have in a certain number of years? It's going to be later on, like, hey, I want to buy this car and it's $120,000. How much is it going to cost me per month if I want to pay it off in 4 years or 5 years or 10 years, right? So amortization and loans and that kind of stuff, right? So that's what we're getting into here. It's really kind of cool because it's really useful math. Okay. Formulas, we're going to go over a couple here. You don't have to memorize, so don't be freaked out about it. They're going to be here for you in your toolkit, ready for you to use at all times. Okay. So know how to use them, right? Know them well enough that you can use them very easily, but you don't have to worry about memorizing. Okie dokes. All right, here we go. So what we're talking about here is compounded interest. We're talking about putting money in a bank, and the bank is paying you because they take that money you put in and they loan it to people for houses and cars, and that's how they make their money. They give you 2% interest. They charge them 5% interest. That means on that money, the bank is making 3% interest. That's the whole idea of banks, right? That's how they make their money. One of the important ways that they make their money. Okay, cool. So, two different formulas you've seen before. I'm going to do the formulas and then we'll say what everything is. A equals P times 1 plus R divided by N. It's R divided by N. And then this will be raised to the N times T power or the NT power. You don't always have to have that little dot there. Okay. A is the amount that you have at the end. P will be, it's called principal. It's the amount that you have at the beginning. So what did you start with? What did you put in the bank? Amount at the beginning. R is going to be the interest rate. And it's important to understand this is as a decimal, not as a percentage. So as a decimal. So for example, 3.5%, you would use 0.035. Okay. We're not going to put 3.5 into this formula. We're going to put 0.035 into this formula. N is going to be the number of compounds in a time period T. T is the time period. All right, let's go over what compounds mean because this generally is the trickiest part. Okay. The idea is this. If I went to a bank and I put in $10,000 way back when, if they said, hey, I'll give you 10% interest, I'd have to leave it in for the full year. And at the end of the year, they would press calculate and they'd be like, now you have $11,000. And I would wait another year. And at the end of that year, they'd calculate and they'd be like, oh, hey, guess what? Now you have $12,100, right? So they give me 10% a year, but they're waiting till the end of the year to apply that interest, right? I don't want to wait. So I go to my bank and I say, hey, it's been half a year. Why don't you just give me 5% now and then give me 5% at the end of the year? Okay. That would be two compounds per year. That's the idea. I would compound twice a year, once halfway through the year, and then once again. So that would be every 6 months. I could also go and say, hey, let's do this quarterly, right? Let's do this 4 times a year. So every 3 months, you're going to give me 2.5%. Over the year, that's going to add up to 10%, right? 2.5, 2.5, 2.5, 2.5. It's actually going to be a little bit more because of compounding. But bank's like, okay, that sounds fair enough, right? It's a little more work for us. Well, as you know, people develop calculators. There's a calculator. Whoa, it's like invisible. Oh, magic calculator. So fun. Calculators and I don't know, abacuses, abaci? What's the plural of abacus? Uh, calculators, computers, that kind of stuff. It made it easier to compound smaller and smaller periods. Okay. So we'll give you some examples here. Example, if we compound monthly, then N would be 12. If we compound quarterly, N would be 4. If we compound daily, N would be 365. Some of you would be like 365.25 because of the leap year, and that's fine too. You could do that if you want to. So cool, cool. That's that. All right, so let's use it. Mr. Smith saves this much in a bank. That's the P, right? That's the principal right there. That earns 5.2% interest. So that's 0.052 as a decimal. Compounded monthly. As soon as I see that, I know N is equal to 12. And then how much is going to be in 12 years? So that's T is equal to 10. So I've got, I think, everything that I need, right? All right, this equals little r. Let's go for it. So amount at the end is equal to P, which is my principal, right? Principal times 1 plus R over N. My R is 0.052. I have to swerve down a little bit because my writing there, divided by my N value, which is 12. And we're going to multiply this time by 12 times 10, right? The N times the T. Okie dokies. Incidentally, I know some of you are like, why is this one here? The idea is this. Let's say I had $10,000, right? I'll just do a little up here, right? And I had just one compound. So one, and this was 1 plus zero point 0.1, right? That would be my zero point 0.1 over 1. Let's say at the end of the year, like I said at the beginning, I put 10,000 in the bank. At the end of the year, they gave me 10%, right? If I distributed this, this would be $10,000. This is my original amount. So this one here means I get to keep the principal, right? I get to keep that. And then this plus, this is my interest, right? 10% of 10,000 is 1,000. So this is 10,000 plus 1,000. This is my additional interest that I get. So this is, I get to keep my original amount. This is the extra money that I get for saving the money in the bank so they can go lend it out to other people. Does that make sense? Okay. Understanding this formula makes it a little easier to use. You kind of get what's going on, and that's kind of important. Okay. All right, here we go. I'm going to do this. When I work on these problems, when I plug this in, there's lots of ways that it can get messed up. So what I do is I work from the inside out. I'm going to start with this. Clear, clear. I don't know what's happening. Oh my gosh, there's just too much stuff in there. All right, forget it. Forget it. What is happening? Okay. 0.052 divided by 12 equals. There we go. Okay, so that's that. I'm going to add it to 1. I'm going to take that to the 120th power. There we go. This is what I'm going to multiply by 25,000. You could just plug this whole thing in and maybe get there all at once. I like to take it step at a time so I don't mess up. So the amount at the end is about equal to $42,003.48. I'll round to the nearest penny. There we go. Not bad. Not bad, Mr. Smith. All right, let's move on. Let's do compounded continuously. So if we can do monthly or quarterly, we could do daily, we could do every hour on the hour, we could do every minute, we could ever do every millisecond. We could keep making these periods smaller, and you're actually going to get more and more money until you make them so infinitesimally small that you are compounding continuously, right? You are never not compounding. So the formula for that is, you may remember, P times E raised to the R times T. Okay, so this is E raised to this, and then we multiply it by P. A is the amount at the end. P is the amount at the beginning. R is the interest rate as a decimal. Sounds familiar, right? T is time. So basically, these are the same as these. No difference, right? What we do have here that's a little different is this letter E. Okay, this is not a variable, not a variable. It is a number. It's the natural number. It's the most important number in the world right now. Okay. It's kind of like pi. I think I've explained this before. Pi is a little bit bigger than 3. E is a little bit smaller than 3. E is about equal to 2.7. I think it's 1 something. I used to have the first like 4 or 5 digits memorized. It's kind of like pi. It goes forever. It doesn't repeat. We could have an E day. 2.7, February 7th. I don't know. Maybe we should. Maybe we shouldn't. Because it is probably a more important number than pi nowadays. Because all of your um, financial transactions, your credit cards, your mortgages, your loans, your money in a savings account or whatever are affected by this formula pretty much, right? And this E right here is central to that formula. So pretty important number. All right, Mr. Smith says same amount, same interest rate, same years, but this says compounded continuously. When you see the words compounded continuously, you use the continuous formula, which is A equals per. All right, so let's plug it in. A equals P, which is my principal, 25,000 times E. Oops, I don't need that. I started looking over there. Times E raised to the R, 0.052 times T, which is 10. Cool. Let's just try plugging all of that in. Let's go. 25000. Okay. Where to find E? There's two different places. If you go down here to ln, oops, sorry, I don't have that on the screen. If you go down the left side of your calculator to ln, you'll see right above it is E raised to the X power. That's a good one, especially if you want the um, uh, exponent going on. You want to put something in the exponent, which we do. The other one, if you go to the very right side and go about almost halfway down, right on the above the division sign is E as well. But this one doesn't give you, you'll have to create your own. You'll use the arrow or the caret key to go up into the exponent. So you could use this still, but then you've got another thing to do. So I like to go second ln, and that gives me E to the blank. And now I'm going to put in what needs to be there. It's going to be 0.052 times 10. Notice that's all up there. If this was an old calculator, I might put those in parentheses to make sure it stays um, up in there. So I press enter and 42050.69. 42050.69. And we can compare, right? Hey, look, $47 more. All right. Now, it doesn't seem like that big of a deal. Over 10 years, $47. That's like $4 extra a year. That's one coffee drink almost, right? That's not bad. Per year, you could treat yourself. But if this was instead of 25,000, what if this was 25 million? We'd be talking about like, $50,000. That's kind of a big deal, right? What if you left it in for more than 10 years? It's 20 or 30 or 50 years or something like that. Then it compounds, it gets even bigger. So compounding is powerful and it's big and it's going to be a central part of what we do the rest of the semester. All right, people, we'll see you. Good work.